Okay, moving on. Now we want to write the standard form of the equation just from the graph. This is pretty simple, and looking at the features and then writing them in the equation. I think this is the third exercise in the unit on Khan Academy. Ellipses, standard form, and graph, I believe is the name. But on the left, we have the graph. On the right, the standard form equation of an ellipse. And let's look at the standard form equation of an ellipse. You have the x minus h squared over a squared plus y minus k squared over b squared is equal to 1. We're going to focus on the equation for a little bit and then look at how we can find this information from the graph, and then I will work out 2 examples. So, if we look at the equation, if we cover up the a squared and the b squared, then it's just the equation of a circle. In fact, it's the equation of the unit circle with center at hk. And then we have this a squared and b squared on the bottom. Those are the new additions for an ellipse, a squared and b squared, which correspond to radii, the radius that we see on the ellipse. In a circle, both of these denominators would be the same, and so we just multiply it out, and that's where we get x squared plus y squared equals r squared for a circle. But for an ellipse, because the circle has been stretched, it's different. So we have a horizontal radius and a vertical radius. Now notice, under the variable x, I put a squared because that goes with the horizontal radius. And under the variable y, I put b squared because that goes with the vertical radius. So we have names like major axis and minor axis, but when it comes to the algebra, it's really the association. If something is associated with x, if it's grouped in with the x variable, it's going to act horizontal. So this denominator under x tells me the horizontal radius. And this denominator under y tells me the vertical radius. So I can see from the equation that all I have to do in order to go from the graph to the equation is identify the center and the lengths of the horizontal and vertical radius. So now we're going to look at the graph and see if we can identify these things. The center here is just going to be the ordered pair, hk. You'll notice color-coded, so the center in red, the values that go in the equation also in red. My horizontal axis, which may or may not be the major axis. It might be the longest one, it might be the shortest one, we don't know. But the horizontal axis is A, and so we get that, and that goes under the x minus h squared, whatever my horizontal radius value is, goes under there and gets squared. The vertical axis, B, could be the minor axis, could be the major axis. We don't know until we see the graph, but whatever that radius value is from the center out to the endpoint goes under y as b squared. And the reason it's squared on the bottom is because this exponent on the top actually groups the entire thing. Everything is inside opposite for these, which I'll talk about later in a different video. But so now we've got these relations, standard form equation, the hk for the center, horizontal radius, vertical radius. So if we have a graph and we want to write the standard form equation of the ellipse, we just find the ordered pair for the center, the length of the horizontal radius and the length of the vertical radius, and then place them in this equation in the proper places. So let's look at a couple examples of that. Example 1. It wants me to write the standard form equation of this ellipse. So I need to identify its center And then I need to identify the horizontal radius and the vertical radius. So looking, we see that the center is at 1, negative 2. So I'm going to use the ordered pair 1, negative 2. And then I need to find the length of A and B, which is the horizontal radius, and B is the vertical radius. So I look A, from the center, I just go horizontally until I reach an endpoint, which in this case, because I can see that the horizontal axis is the larger axis, that would be the major axis, which means that endpoint is a vertex. Remember, the vertices are always along the major axis. The co-vertices would be along the minor axis. In this case, I can see my scale is 1. So 1, 2, 3, 4. The length of my horizontal radius is 4. And then doing the same thing for my vertical radius from the center to a co-vertex here is 2. Remember, this is A, this is B in this particular representation. So now I can just fill in the parts of my standard form equation. Starting with the x values, x minus h, so minus 1 squared over the horizontal radius squared, which was 4, so we're going to get 16. Plus y minus k squared, so y minus the value of negative 2 is going to change that to a positive 2, so we get that inside opposite squared. Over the vertical radius, which we found was 2, so 2 squared is 4, and then is equal to 1. So just like that, we get the standard form equation of the ellipse from analyzing the graph and finding those features. Let's do another one. This ellipse. Okay. Again, we're going to find the center of the ellipse. We're going to find its horizontal radius and its vertical radius. So that's what I need. The center. I need to find the horizontal radius and the vertical radius. Center, we look, 2, and then it looks like negative 1 here, which we can find just by counting. So I go 1, 1, 2, 3, 4, so right there is the middle of the horizontal, and then up and down, if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so 6, so wait, 1, 2, 3, 4, 5, 6, right there. So again, nothing fancy, just finding the middle of the whole thing, right there is my center at x equals 2, y equals negative 1, so 2, negative 1. And then just like we did on the other one, we want to find the horizontal radius and the vertical radius, which if we have the endpoints, then we can just do the distance formula or just subtraction. But in this case, I'm going to just count. So we have 1, 2. Horizontal from the center is that radius, which is 2. So the horizontal radius is 2. For the vertical radius, I'm going to say that I know this coordinate. It's at 2 and negative 7. So I could, like I said, I could just count the scale. But if I don't have a scale or it's not easy and I know what the ordered pair for that endpoint is, I can just use subtraction to find that radius easily as well. Notice the horizontal value stayed the same because our radius is vertical. So we're just going to have to subtract -7 and -1. Since it's a radius, largest minus smallest is what we want. So it's -1 minus -7. So this vertical radius will be -1 minus -7 using the ordered pairs, the y coordinates of the ordered pairs for that, which is 6. So the horizontal radius is 2. The vertical radius in this case is 6, and that gives me enough information to write my standard form equation x minus h2 squared over the horizontal radius squared, so that's 4, plus y minus k squared, it's a -1, so I know minus a -1 becomes +1 squared, over the vertical radius squared, which we found to be 6. 6 squared is 36, equal to 1, would be my standard form equation of that ellipse.